Hi, good morning, guys. Today we can see transplantation immunology. In this session, I am giving a very simple introduction to transplantation. Transplantation, it is the implantation of tissue or organ into a host or an individual. Tissue or organ implanted, it is called graft, and the person receiving the graft is called recipient, and the person donating the graft is called donor. So, graft, donor, and recipient are the three important terms in transplantation immunology. Transplantation immunology deals with immune response mounted by the host to an implanted graft. That is, in some cases, this transplanted graft it can act as completely a foreign substance in the host. As a result, the host immune system it start responding to the graft. It produce a vigorous reaction resulting in complete destruction of graft, and the result will be the complete graft rejection. We can see live and dead organ donors. Next we can see the types of transplants. There are mainly four types of transplants: autograft, allograft, isograft, and xenograft. In this simple diagram, we can see autograft, it is occurring in the same individual. Isograft, it is occurring in genetically identical individuals. Allograft, it is occurring in individuals which are genetically different and they are belonging to the same species. And in xenograft, this organ transplantation, it is occurring between two different species. Coming to the details, we can see autograft. We have already heard about plastic surgery. It is a very important example of autograft transplantation. That is, the self tissue, it is transferred from the body, that is from one body site to another site in the same individual. This occurs in person who has lost their tissues due to some accidents, some burns or other injuries. As it is occurring in the same individual, there is no chance of graft rejection. That is, there is no difference in major histocompatibility complex antigens, so the graft will be completely accepted. Transferring healthy skin to burned area, use of healthy blood vessels to replace blocked coronary arteries, plastic surgery of skin, etc. are the main examples of autograft transplantation, and it is widely employed in medical science. This is the diagrammatic representation of skin grafting, and this is the repair site. Next we can see isograft, or it is also known as syngraft. Here the tissue or organ it is transferred between genetically identical individuals of the same species. It is mainly occurring in identical twins. One specialty of identical twins is that their histocompatibility antigens are also identical. So, there is no chance of graft rejection. The graft survives and the transplantation will be completely successful. Third one is allograft. In allograft, tissue or organ it is transplanted between genetically different members of the same species. This type of transplantation it is widely seen nowadays. For example, transplantation of liver, kidney, heart, bone marrow transplantation, lung transplantation, etc. are widely employed in medical science for treating many persons with impaired organs. In allograft, histocompatibility antigens are highly dissimilar because there is no similarity between the recipient and the donor. So, the chance of immune response is very high. That is, the immune response will be elicited in most of the cases and the graft will be rejected, and the graft acceptance it is a rare case. Nowadays, the graft acceptance it is increased by employing some immunosuppressive drugs. And this is the most important type or most widely used transplantation in medical field. These all organs can be transferred from one person to another. Last one is xenograft. Xenograft, here the tissue it is transferred between two different species. That is, the graft can be transferred from human to animals and vice versa. In xenograft, the major histocompatibility complex antigens are so different so that the graft is more vigorously rejected. So it is not widely or it is not employed at all. Next we can see a small introduction to allograft rejection. Allograft rejection, we can see alloantigens, they can elicit both cell-mediated and humoral immune responses. And the rate of graft rejection, it varies with the type of tissue transplanted. If a skin graft is done, it is rejected faster than that of organ transplantation. That is, skin graft, it is rejected faster than organs such as kidney or heart. One example is that strain A, that is a mouse of strain A, is grafted with the skin from the strain B. The chance of graft rejection is very high, and we can see the first graft rejection or the primary response, it will be occurring within days and it is called first set rejection. And if we are attempting the same for the second time, we can see that the strain A, it show graft rejection for the second time also, and the rejection will be much more faster and it is called second set rejection. In the diagram we can see simply understand from this diagram, that is, this is the strain A and this is strain B, and from strain B the skin graft it is transplanted to strain A, and we can see the first set rejection occurs within 14 days, maximum 14 days. And if we are doing the same for the second time, that is transplantation of the skin to strain A for the second time, it results in second set rejection, or it is similar to secondary immune response, and it is much more faster and it occurs within 6 days. This diagram shows graft acceptance, first set rejection and second set rejection. First we can see autograft acceptance. If autograft transplantation is done, we have already seen the graft will be completely accepted as the transplantation it is occurring in the same individual, that is the donor and the recipient is the same individual. And this is the grafted epidermis or the grafted skin, and the blood vessels, they undergo revascularization within 3 to 7 days, and the complete healing occurs within 7 to 10 days, and these neutrophils migrate to the site and complete resolution occurs within 12 to 14 days, and the graft is completely accepted. Okay, and in the first set rejection we can see the graft epidermis is this. Here already we can see a color change, and this graft epidermis, here also revascularization occurs within 3 to 7 days, but within 7 to 10 days cellular infiltration occurs, that is neutrophils, macrophages, monocytes, etc. migrate to the site and they identify this graft as a foreign substance, resulting in thrombosis and necrosis and the complete damage of blood vessels, leading to the complete graft rejection, or that is first set rejection. Then coming to the second set rejection, we can see the grafted epidermis, it is first accepted, then within 3 to 4 days cellular infiltration occurs, that is it is much more faster when compared to first set rejection because of immunological memory. Within 5 to 6 days we can see thrombosis and necrosis resulting in tissue damage and the complete destruction of the graft, resulting in a vigorous or serious graft rejection. Here we can see the points again. In first set rejection, the skin revascularized within 3 to 7 days. Then the transplant get infiltrated with lymphocytes, monocytes, neutrophils and other inflammatory cells. Vascularization decreased by 7 to 10 days. Complete rejection occurs within 12 to 14 days. Graft rejection has high specificity and immunological memory, so the second set rejection it is much more faster and it occurs within 5 to 6 days. That's all about the introduction to transplantation immunology. Hope you all understand the session. Thank you and stay safe.